This lesson is on products and quotients of rational expressions, also known as multiplying and dividing fractions. And it's not just numbers, it also includes variables, and it will also involve factoring. So, let's get started. Let's start with this rule for multiplying fractions. The rule for multiplying fractions is that we are going to multiply straight across the numerator, a times c, and then straight across the denominator. Pretty easy. Now division, we're not going to multiply straight across because we have this division. Division is an opposite action of multiplication, and the rule for division is multiplying the reciprocal. So we are going to multiply the reciprocal of c over d, which is d over c. Once you write it as a multiplication, then you can multiply straight across. So let's simplify some of these. We can, for example 1, we can multiply straight across and then cancel, and that would be 120 over 120. And this one was pretty easy to end up reducing, but here's an alternate way to do it. If you wish to cancel as you go, see 10 and 15 both have a common factor of 5. And then 3 will go into 12 4 times. And 4 times 2 is 8, and that cancels, and that leaves a 1. You could do it that way if you wish, or you can simply multiply across. Sometimes it's going to be easier to multiply across, and other times it will be easier to reduce as you go. So we have this division, which means we're going to need to flip the second fraction, and it does matter the order, only flip the one that's after the division. And we're going to flip this and multiply. Now I see that I can go ahead and cancel out the 6 with the 18 and write down what's left, which is 21 over 2. Yeah, let's go to example 3. Now example 3 has a lot going on, and so sometimes I like to rewrite mine as 3 fractions, and I'm going to start with multiplying my numbers. And I'm going to write my variables. We're just going to write it all together. Correct my right-o. Okay. Now I'm going to begin with reducing my numbers. (36) and 60 both have a common factor of 12. So you divide out a 12 for both of these. It gives you 3 there and gives you 5 here. So I've got 3 over 5. Now the y's, I have a y squared on top and a y squared on bottom, so if I divide those, that makes a 1. And with the z, I'm going to subtract those exponents and put it on top. Let's write the correct color. So z to the 4th. And I guess I didn't need this much of a line. So let's go to the next example. Alright. I've got some binomials and some trinomials, which means I need to do some factoring. So a cubed minus 6a squared has a common factor of a squared, which leaves a minus 6. And a squared minus 2a plus 1 factors into a minus 1, but write it completely factored. And then in my numerator, a squared plus 2a minus 3 factors into a plus 3, a minus 1, and then times a cubed. So let's see what we can cancel. There is no a minus 6, so we're going to keep that. And we have two a minus 1s on top and 1 on the bottom. So I'm going to cancel the 1 out. And I have two a squareds on top and 3 on the bottom, so it cancels that one out completely. So let's come back and write what we have left. We have a minus 6, and then a minus 1, and then in the denominator we have a times a plus 3. Leave it factored, and that is your answer. Okay. Example 5. Now I have a division and a multiplication. Only flip the 1 following the division sign. So 9 over 10 is the only thing we're going to turn over. So I've got 21 over 10 times 10 over 9 times negative 4 over 7. Now what I see is I have a single negative, so I'm going to write that so I don't lose it. And I could multiply all those across, but I see really easily that I have some common factors. So I'm going to cancel out the 10s, and the 7 goes into the 21 evenly, and then that 3 goes into the 9 evenly. So what do I have left? I have 4 on the top and 3 on the bottom, and I went ahead and put my negative out. Okay, so example 6. I see I've got a single division. Always divide after the divide, or flip after the division. So I'm going to write my problem with everything flipped the way it should be. And we can start canceling. So I see the 5 will go into 25. And I have 1y on the bottom and 1y on the top. And the negative 7, I'm going to cross out the negative, also goes with the negative 14. That goes in 2 times. And this 2 cancels. So let's see what we have left. Well, I've got y cubed and a 3 and the 5 on the bottom. And now that's all that's left. Okay, last one. Alright, I see a couple of things going on. I need to flip this because of the division. But I have a negative right here, which means I also need to flip this because this is saying take a reciprocal. So in this case, we get to turn 2 things over. So here's my first fraction I'm flipping over. And here's my second fraction I'm flipping over. Alright, so let's do some factoring. So I've got x minus 1, x plus 1. I'm just going to go straight across the top. X minus 2, and then I have another x minus 2, x minus 4, and then on the bottom I have x plus 2, x plus 1, and x minus 1. Okay, so we're going to cancel that one, and I have an x plus 1 here. And I think that might be all. So what I am left with, oh, no I'm not. That's an x plus 2. Let's correct that one. Awesome. Okay, now I can cancel the x plus 2's. And what I have left are 2x minus 2, so I'm going to write this squared, like so.